New and shiny features often get the largest spotlight in major PHP release announcements. But there's always a lot of improvements on the performance, debugging and operations side that are mentioned as just a footnote or not at all. In this video, I'm going to show you 7 performance, debugging and operations changes in PHP 8.4 that you have probably not heard about before. Moin, my name is Benjamin and I'm working on performance optimizations for PHP applications for the last 10 years, helping thousands of developers along the way. The first change is the sprintf compiler optimization. Starting with PHP 8.4, if you use sprintf with only the %s or %d modifiers, then it compiles down as if you were using string interpolation, and it avoids the function call overhead of sprintf completely. This change I am truly proud of, as my colleague Tim implemented it and put a lot of work into getting this into core. Let's see how this works. So on our blog, we show an example of how this works. If you have a function that concatenates strings in any way, then you can use sprintf now. Here we use just the %d modifiers to generate the string. And with PHP 8.4, the PHP engine and opcache optimizes this to become this string interpolation code here instead. So the sprintf call is gone completely, and with it also the slight performance overhead of calling this function. So the benefit I see here is that you can modify a lot of string manipulation code to use sprintf instead, because it is much easier to read in my experience, and it allows you to make better use of this function and don't think about the overhead of that, because PHP will optimize this away for you. So you end up with a more readable code that manipulates strings, and it doesn't even cause this script to run slower. The second change I want to talk about is the deprecated attribute, a feature that my colleague Tim and I proposed and finalized for PHP 8.4. Originally, when I worked on attribute support for PHP 8.0 in 2020, my idea was to also include the deprecate attribute directly in this version to have one use case for people to immediately try this out and use for themselves. But sadly, I hadn't had the time to finish it. Now this is complete, it's in 8.4, and you can put it onto functions and methods, and starting with 8.5 also on constants, and maybe we will also add support for adding it on classes in the next version of PHP. How does it work? Let's look at a simple code example. I have a calculator class with a method add that's working on integer types, and I want to add a new method that allows to work on integers and floats. So I'm deprecating the old one using the attribute, and if I run this code now, you can see PHP deprecated. It will show a deprecation error or deprecation message. The function is deprecated, and it's also using this alternative text here that I added above. You can also specify a version, since when. So I could say, for example, since today, this method is deprecated. So and this will include it in the message as well. So if I use the new method now, not the deprecated anymore, the engine will not run through this deprecation attribute while this function is called, will not trigger this deprecation. And this is a good way to replace deprecation code that you could do before using trigger error and then user deprecated, and using the attribute is way simpler to do. The third feature that is included in PHP 8.4 that I want to talk about is lazy objects. And Doctrine and Symfony are known for their use of lazy objects and proxies for a long time already, but they implemented it in userland using code generation and magic methods. And finally, this is now possible to use in the engine directly with this new functionality. And it adds some hooks that make it possible to completely skip code generation and other magic ways to like implementing lazy objects. In Athens, lazy objects allow you to defer constructing the object to the point where any lazy properties are accessed on this object for the first time. There's a lot of nuance to it. It can be used in very advanced ways, but I want to talk about a simple way how this works. I want to show you a simple example how lazy objects work in dependency injection. I have an expensive dependency class with a constructor calling the sleep function. It simulates expensive behavior in the constructor that we see in real-world applications as well. Not this critical here with the sleep, but doing work like connecting to external services or performing some initial work, signing things or so, opening files. And this is not necessary in most cases when the object itself is then later not used. So the expensive dependency is injected into this myListener through the constructor, and we have a public method on that. So in PHP 8.3 and before, you would create this dependency using new expensive dependency, and at that point it would trigger the slow code. With PHP 8.4, you can use the reflection API to create a new lazy ghost object. So it looks like the real object, but it's actually not initialized yet. And we have to pass the new lazy ghost in initializer function. And this is triggered once the object is loaded. And for our case here, we need to initialize the object, and we can do that by calling the constructor directly. So this looks a bit weird. This is the way you can use this, because you can call the constructor multiple times on objects, and the lazy API sort of circumvents calling the constructor. So here we have the listener, and now we have this lazy dependency, and if we call this code here, it will show that we have an instance of the myListener with the expensive dependency. And as you have seen, the code exits very quickly, so the sleep call hasn't been triggered by this. The fourth change I want to show is something that my colleague Tim worked on, the SHA-NI integration for SHA-256 functions. So cryptographic algorithms can be much faster when they are directly implemented on the CPU using CPU instructions. And that is what the SHA extensions SHA-NI are for the SHA-256 functions, the hash algorithm. PHP core now supports using these extensions in the hash algorithm, basing it on the excellent work in the tarsnap libc Percival library. So this is something that existed before, and now this library is used in PHP to implement this functionality. In his pull request, Tim also showed some benchmark work. So if we go down here, so he has some before and after checks and a direct comparison at the bottom. You can see he runs his changed PHP against sort of the master version at that point. So the PHP version binary that didn't have these changes. And then he runs a very simple loop with an algorithm and performing some work on data. So you can see here in the direct comparison for the SHA-256 algorithm that it runs 2.3 times to 5.2 times faster than the original SHA-256 code. So it's really faster, much faster than before. It's even faster than the implementation of the MD5 function in PHP. So if you have code that is generating a lot of hashes to identify strings or files or something like this, then it's worth looking into if you want to change to SHA-256 instead, using both a more cryptographically unique and secure function, but also having faster results for that. The fifth change I want to show is an individual performance improvement to the getBrowser function. This function can be used to detect crawlers and bots that are running on your website and maybe to block them or to do some special handling. The way PHP implements it is by parsing an INI file called browser-cap, which includes a lot of definitions of crawlers and bots, and this file is updated regularly. And in the PHP code, when it runs, it will pass this INI file and then match the user agent against it. So Niels Dösche performed some performance work on that, and he also included a benchmark where he shows that for different scenarios, his changes improve the performance by 1.4 to 2.5 times. However, this is a special case that we need to talk about because there are also some userland libraries that do the same thing. So JBizzle crawler detect and Matomo device detector. And previously we benchmarked them against getBrowser to see which one is faster and what you can use. And the PHP-based implementations have one benefit. They use the browser-cap file or a different input for user agents and code generate a PHP parser that checks for this. And by doing so, the PHP parser, the code for that, can already be stored in opcode, and it can already be stored in opcache. And this makes it much faster than the getBrowser native function because it needs to pass the INI file. So when we benchmarked this before PHP 8.4, you can see here that getBrowser is quite expensive and runs in the many seconds time, whereas the two PHP libraries are much faster and run in the sub 1 second performance range. And for calling them only once, also getBrowser is slower than the Matomo device detector or JBizzle crawler detect. So this is the case where the performance improves for the PHP internal function, but still there are userland implementations that are faster. Change number 6 that I want to talk about is the DOM HTML5 parsing and serialization RFC. It uses a new library called Lexbor, which is used to implement parsing of HTML5 code or HTML5 compatible code. And this was previously not possible in PHP because the DOM document parser was based on older HTML standards. And now we have HTML5 support in PHP. This also includes performance improvements because the parsing of HTML5 code is now faster than the old parsing code. And additionally, the new API includes implementations for CSS selectors. And previously, you would need a PHP-based CSS selector library for that. And that's now implemented on the C level. And if you're using CSS selectors a lot, then this will also give you a performance benefit. You would also don't need to convert it to XParse anymore, so it's easier to work with. Let's look at some code. We see the old way of parsing HTML code is using the old DOM document class, calling the load HTML method. And the new way is using a new HTML document class from the DOM namespace, calling a static create from string method. So let's run this through a benchmarking tool. We use Hyperfine here to compare the call with the old code against running it against the new code. And I'm using the HTML output from a news website, a German one, Spiegel.de. They have like super big HTML nested things, so it's very complex HTML and the parsing takes quite a while. So let's run this against each other. We see that for the old code, 10 parsing runs take 327 milliseconds. and for the new it takes 207 just. So the difference really is about 1.5 times faster using the new parser. So if your PHP application parses HTML code a lot, you should change to this new API for performance reasons, but also because it parses the HTML code more correctly. Change number 7, and the last change I want to show, is closure naming in Stacktraces. When you regularly use closures and debug code with them, you might have come across the problem that in a stack trace, the closure is not uniquely identified. You see that there is a closure in the stack, but you don't know where it was defined. And if your application passes around closures a lot, then maybe you don't know what the code is that is being executed, causing an error. So starting with PHP 8.4, this changes a little bit. So here we see the old way is rendering closure. So there's a closure that was declared in this namespace here. But obviously this namespace could have tens of hundreds of closures. So with PHP 8.4, the change is that a closure defines where it was coming from. So you can see here that at that point in the stack trace, we have a closure that was declared in the storefront controller render front function on line 26. So now it's easier to identify which specific closure is part of a stack trace. This is also true if you var dump closure objects. They also include this information now. And an additional benefit is that this kind of things are now also visible in error tracking tools, and for example Tideways shows this now, and you have like an easier way of identifying which code was run in an error. These were 7 changes in PHP 8.4 that you might have not heard about in detail yet or at all. And PHP 8.4 is now already out for a few months, but migrating to it started like picking up recently. So maybe you are in the process of migrating to 8.4 right now, and I hope you found something that you can use to improve the performance of your application. Coming up on the channel next, a video on the performance between versions PHP 8.4, 8.3, 8.2, and why it's not changing a lot anymore in recent times. Also, if you want to watch PHP performance related topics in general, please subscribe to this channel or to the newsletter. The link is in the description. Bye!